All right, so we're continuing to round down. That's what the greatest integer tells us to do, round down. All right, pi is 3.14. So if we did 3 times 3.14, that'd be 9.42. And 9.42 would round down to 9. Now here's where it gets tricky. It's -7. It's really close to -6, but we have to round it down to the previous integer, which is -7. What's the previous integer for 0.2? 0. What's the previous integer for -9.1? -10.
Why would -6.1 not be -6?
It has to round down to the previous. So -6.1 would be about right here. If we're rounding down, we have to go that direction.
Oh.
All
okay,
these are
okay.
rounding
You're right.
down. Okay. So this makes -50. Okay. Kind of got a grasp of what it means to evaluate a greatest integer. Okay, so if you'll flip over to the back, I want you to try 1 through 10.
1 through 10.
This could have been your homework, but it's really your classwork, which counts as a homework. It's a good deal.
That was the rumor I heard.
It was good rumor, wasn't it?
I told you it was good rumor.
Let me know if you need some help.
This is all we're doing?
It's the beginning.
Yeah, you're right, because the cube root of 8 is 2.
What? What's the question?
30 or 40. Maximum speed limit.
30, I think. Always go down. Sam, I screenshot Mike. Story.
Yeah, would you choose 6.2 -6.2?
Please, just let it finish. It's so important.
Is that what you got?
It's my first life. That's why he's an angel. Why is he because he was deciding without me.
Isn't that dangerous?
Very nice. No, but see, I've already answered every section. There's 10 quizzes, and I've passed every single one, and now let's just let them come on. I'm a great driver.
Oh, there's a great driver. I'm listening to Nicole Connor's a great driver.
Yeah, just say that. Like I said, always just go with the safest.
How do you -square root of 10?
Just find the square root of 10.
Just do
What is
square root of
that?
10 and then put a negative in front of it.
Then put negative root of it. What is it?
3.16.
So it would be -4.
Good job, Claire.
What's the square root of 8?
2.82.
I've been doing it for so long. means I'm done.
I gotta actually.
How do I owe you?
The only thanks you can give me is not crashing.
Okay. I'm so happy. It just helped me out with just like 5 things.
So why is that
Okay.
2 and that's negative?
That's not good. Do you know you can get kicked out of college or something like that?
Are you gonna kick me out of college?
Not for driver's ed, right?
So you just want to do 1 through 10?
Alright.
Thank you for doing the last 5, Stan.
Yeah.
Okay. So on these, we're rounding down to the previous integer. These are rounding down functions. So let's just put some little numbers on our number line here. Then we can play with these.
If you round down.
All right, so 2.65, the positive numbers are usually pretty easy. This would round down to 2. The negative numbers are trickier. So negative 3.25 would be about right here. So if we round down to the previous one, it would be negative 4. Square root of 8. Bigger than the square root of 4. Less than the square root of 9. So it's somewhere in between 2 and 3. So it would round down to 2. Very good. All right, pi. It's about 3.14. So if we did 3.14 times negative 2, that is negative 6.28, which would round down to
Negative 7.
negative 7. 8.2 would round down to 8. All right, square root of 10, a little bit bigger than square root of 9.
Is it 4?
So it'd have to be 3 point something. Let's say 3.1. Right? So negative 3.1 would round down to
No, like pi. What is the number?
negative 4. Make sense? Okay, negative 13.75 would round down to negative 14. This is about positive 6.28, so it would round down to 6. This would round down to 25.
Negative
And that would round down to negative 3. Very good.
What is pi used for?
Pi is the ratio of the circumference to the diameter. A lot of times when we get something that's circular, it is in terms of pi. Yes.
Real world application.
Greatest integer stuff?
Yeah.
Alright. So that's what we're doing tomorrow. I can't think of a single real world application of that. None. That's a little obnoxious, honestly. But step functions do have real world application. Have you guys ever been into a parking deck where if you're there from 0 minutes to 1 hour, you pay this amount? If you're there between 1 hour and whatever up to 2 hours, you pay this amount. All those end up being step functions, because whether I'm sitting in that parking deck for 2 minutes, I had to run in and get something, or if I'm there 59 minutes, I still have to pay the same $5. Now, do we graphically model those situations?
No,
Not really.
never.
No. Could we algebraically model them so that we can do statistics with our data? Yes. So, the graphic models are not as much in context as the algebraic models. Calculator part, so you can grab your
I'm
paper.
getting the wrong answers.
What did I get wrong?
Okay. So that was tomorrow we're gonna look at some situations that do result in step functions, and they are situations that work just like that. Okay, so let's actually look at the graphs now, even though we just laid out there that we probably won't be looking at the graphic models often. But what do they look like? They're kind of interesting, actually. I'm going to do a table, but I don't want you to copy this at all. Don't copy this table. So I'm going to pick some x values. You're going to do it just because I said done. Okay, that's fine. All right. So we're going to pick some values for x. 0.
1.
That is an integer. So it would give us 0. But what about 0.1?
0.1. 0.
Okay, so if I plugged in 0.1 and rounded it down, it would be 0. All right, 0.15.
0.
0. 0.22.
0.
0. 0.37.
0.
0. 0.44.
0.
0. 0.60.
1.
0. 0.72. 0. 0.84. 0. 0.9. 0.99. 0.999. 0.9999.
0.
All right, 1.
Who would have known?
1. Okay? So, if we were to graph this idea, what happens is we start right here at 0, 0. That was my first one. And then I got a little dot right here, 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 a little dot right there. But when I get to 1, I jump up here. So there's a little open circle right here. And every little dot in between 0 and 1 gets filled up. So it ends up looking almost like a little weird barbell. It's got a closed dot on that end. Everything across fills in, and then an open circle on the other. Looks like that. Because every little x value in between, every single one, even though I didn't list every single one, would round down to 0. And then what would happen right here? 1.1 would round down to 1. 1.2 would round down to 1. All the way up to 2. And at 2, we get 2. So 2 gives us 2. And the same thing would happen all the way over to 3. But at 3, it gives us 3. And the same thing would happen all the way over to 4. And the same thing would happen back this way. And do they look like a set of steps? Step function looks like steps. Now, is this function continuous? If I put my finger on the left side of this function, could it travel all the way through the function without ever having to lift it? Nope. It's not continuous.
Nope. See?
It is not continuous. It jumps, and it jumps, and it jumps, and it jumps, and it jumps. We can't trace the whole thing without lifting our finger. Okay, so a step function has jump discontinuity. So you're going to look at, there's a picture on the board of a line that just has a hole missing out of it. That's point discontinuity. It's missing 1 point. That's a rational function. You guys are going to study that in pre-calculus. Those are on the ACT too, so you might want to get a head start on some rational functions. They're fun. But this one is not continuous either. But our domain is, isn't it? We could plug in anything we wanted to for the domain. It was not restricted at all. But our range, we only got out certain numbers. What kind of numbers are these that we got out for our y's? 0, 1, 2, 3, -1, -2, -3. What kinds of numbers are those? They're whole numbers, and when we have these negatives, we also have their opposites. So what set of numbers is the whole numbers and their opposites? I heard somebody say integers. It is the set of integers. That is our range. Because our range is our output. It's every possible y value. And the y's in this example can only be integers. That's it. Now, there's a symbol for this set of integers. It's kind of weird. You know how the double R is the set of real numbers? So you'd think, hey, the double I must be the set of integers. Wrong. It's a Z. That's the set of integers. It's a pretty cool looking Z though, isn't it?
Yeah.
Can I just put a regular
Yeah.
Z?
I'm about
Yeah.
to just draw that.
It's kind of fun when you learn how to do the double Z. Oh, that was terrible. I did a good one up top. Yeah, if you just do a regular Z, I'll give you credit. But it should be the double Z. The double Z represents the set of integers. If you'd rather write the set of integers, go for it.
Don't get mad at me.
All right. Now, these are interesting. X-intercept. When we think x-intercept, we generally think a point. Well, this function intersects the x-axis in an infinite number of points. It's everything on this little line segment right there. So our x-intercept isn't really a point, it's an interval in this case. It goes from 0 all the way to 1. I need you to put that away. So it's not really just one intercept, it's the interval over which this function crosses the x-axis. Does that make sense? Alright, y-intercept, well, we're just going to have one of those. Because if we had more than one, it would fail the vertical line test, and therefore it would not be a function. So it crosses the y-axis just at 0, 0. Now, we can tell it's not even, but if I were to rotate this one little piece right here, this one that's at, and I flopped it over 180 degrees, do you see it's kind of going the wrong direction?
Yes.
So this is neither even nor odd, because if I rotate it 180, it's not going to fall on top of itself. All of these will be neither, for that very same reason. Alright, so now we're going to look at what happens if we have a vertical stretch. What effect does that have on this greatest integer function, the step function? So if we multiply by 3 out in front, well, if I multiply all these by 3, are any of them changing? No. So that first piece doesn't move. But when I get right here and I multiply this by 3, my point is no longer at 1, 1, it's at 1, 3. So this little segment jumps up 3 units. And then the next one would be at 2, 6. And this one would be down here at -1, -3. So what does the 3 out in front do? It causes you to jump by 3 units. So instead of jumping up by 1, we jump up by 3. If this number out in front were a 2, we jump up by 2. Alright, so our domain, still not restricted, but the range. This time, do you guys see that right here, these have a y value of -3. And that little segment has a y value of 0. And this little segment has a y value of +3. And this little segment has a y value of +6. So, what are my y values? What is my output?
Times.
It's multiples of 3. They are multiples of 3. Now, if you get to where you can't describe it in words, like if I had shifted this up or down 1 or 2 before I started, then it wasn't going to be multiples of 3. So if we can't describe it in words, we can always denote it as a set. Ellipse, ellipse, ellipse. The first y value is -3. The next one is 0. The next one is positive 3. The next one is 6. Dot, dot, dot. We can show the pattern. So it's braces at either end of the set, and you show the pattern in the middle. Alright, the x-intercept is from 0 to 1, and the y-intercept is the point 0, 0.
Question.
Yeah.
So with that one, it was a set of integers, and the only thing that changed was you multiplied it by 3. So why does it not? Well, I get that it changes to multiples of 3, but why can't I just make it the set of integers?
Okay, so set of integers means that every single integer is accounted for in the range. If I say set of integers, that means that the range contains every single value in the set of integers.
Mm-hmm.
But when I multiply by 3,
It doesn't.
it no longer contains every value. So that's why I have to denote the difference. In this case, I could say multiples of 3 because these are multiples of 3. But if I had shifted this function up 1, then I'd have 1, 4, 7. And I can't really describe that as a multiple of anything.
Mm-hmm.
So I would have to just show the pattern.
Mm-hmm.
And the reason we do that is because it does not contain every single integer.
Okay.
Real
Okay.
world application.
We started with that.
None.
The graphing.
It's gonna be
We're
on the
gonna-
ACT.
I don't even
Probably
know
not.
that the graphing will be. Tomorrow we're gonna look at 2 applications of step functions. One in terms of postage stamps, I think, and another one in terms of sales tax. Because just like, you know, when you go to the store and you buy something, even though sales tax in Fayette County is 6%, if your sales tax was 0.325, you're not gonna pay 0.5 of a penny because it doesn't exist.
And then you gotta give them a full penny.
Well, we're gonna talk about, would that be a rounding up, would it be a rounding down, would it be a rounding to the nearest? What kind of function do they institute for sales tax?
I'm gonna guess rounding up.
So, we'll,
Yeah, because they're greedy politicians.
a lot of times it is rounding up, and it is because of that.
Try
Okay.
to be like that.
Alright, the next function. It's written right now as 2 minus the greatest integer x. It could be the opposite of the greatest integer x plus 2. Do you guys see that those 2 functions are the same thing?
Yes.
Alright, so what does this 2 do to the function? Shifts it up 2.
Yep.
Okay, but what does the negative out in front of a function do?
Whoops.
Flipping those up.
Okay, so what we have here is a reflection over the x. And shift up 2 units.
Okay. Alright.
Alright,
Yeah.
so what this means for our graph is instead of jumping up, we're going to jump down. Got it?
Yes.
Instead of jumping up, you jump down.
I knew that. You didn't.
Stop fighting. Please.
Can you get your 30-pound head off?
So that negative causes the reflection. Now, doesn't affect our domain. Our range is still every single integer. So I'm going to do the double D.
That one was a good one.
Thank you. The x-intercept, well, it crosses the x-axis over the interval from 2 to 3. And our our y-intercept is just the point 0, 2. And it's always going to be neither. Okay, so there are some interesting things about step functions that I do want to go over. We haven't done a horizontal shift, so let's do one of those real quick. Let's say we had a x plus 2 minus 1. Okay, so when we do the transformations of this function, what we're shifting is that first little greatest integer step. Okay? So the first little barbell, that's what we're moving around. So this barbell is going to get shifted to -2, -1. First barbell. Okay, it's the first step. And then we jump up 1. And then we jump up 1. And then we jump up 1. And then we jump up 1.
It's just so repetitive.
It is kind of repetitive. Now, if I looked at that graph, is there another equation that would give me the exact same graph?
Yes.
Oh yeah, it's actually infinite. Because instead of shifting over 2 and down 1, could I have said, just shift back 1? Would that give me the same graph?
Yep.
Yep. What if I had
Or
said,
you going up 1,
just shift up 1?
or up 2 and over 1.
Yeah.
This is too easy. This will-
All of these give us the same graph. Weird, huh? Alright. Now, let's do one. Let me make sure that's not the exact one you did a second there. So, -2x plus 3. Alright, so where do I start on this one? Where's the first barbell? Up 3. So there's the first one. But this is -2. So am I jumping up or down? Down, and how far?
2.
2. Alright, now this one we didn't skip any. So this one would have a range that's the set of integers. But this one we're skipping some. So let's look at these y values. This is 3, this is 1, -1, -3, -5. Can you tell by looking at it that those are all of our odd integers? So if you can describe it in words, do it. If we're jumping by 2, it's either going to be the set of odd integers or the set of even integers. It just depends on where we start. And because we started with an odd y value, it's a set of odd integers. Alright, now, here's a fun one.
Classy.
That's supposed to be a 2. It's a really weird looking 2. There we go.
But you don't know how to do it, Hayes. I do know how to do it.
Alright.
You start it.
You plug in.
Where do you
plug in
start?
2
for X.
Start at 2.
Start at 1,
Start at 1,
2.
2.
1, 2 is my first closed dot. Now, this is totally different because this one, the x, is being divided by something. Well, if we do anything with the x, it affects our function horizontally.
Absolutely.
So,
it's like
instead
half.
of being a vertical stretch, this is a horizontal stretch. What's the opposite of divided by 2? Multiplying by 2. So instead of this step being 1 unit in length, it is 2 units in length.
I said that.
Okay?
I said that.
Now,
But then you have to
from this
think about
open
it.
circle, I'm going to jump up 3
You have to jump
and go over 2 units. from this closed one, I can back down 3 and go back 2 units.
Why?
I can back down 3 and go back 2 units.
I know.
Question. Why are you going down and back?
Because
Is
I'm
the
trying
opposite
to
of
kind of fill
positive
up my
three?
graph so you
Wow.
can get a good picture of what this function looks
So
like.
would the next one be 5, 4?
It'd be negative.
No, I'm talking about above the starting one.
Oh. The next one was.
It'd start at 5, 4, 5.
Okay, so it's gonna be 5, but we have to
5.
jump up 3, so it would be 5, 8 up here.
What?
It'd be the point 5, 8.
Oh, no, just kidding. I didn't see the one that's in the.
Okay.
Wait.
Yeah, the one that's in the equation when I was talking
Gotcha.
about. I didn't see it.
All right, so let's talk about the range for this one. I've got -4, -1, +2, +5. I can't really describe that in words, so I have to go dot, dot, dot. -4, -1, +2, +5, dot, dot, dot. Okay, you have to give me at least 3 to show the pattern. 4 is better, but you have to give me 3 to show the pattern. Okay, so you try the 3 easy ones at the bottom of the page. This is your homework grade.
This.
Yeah, these 3 right here. Those 3 right there.
Dude, I think I have fortune from 43. It's embarrassing. Bro, this doesn't look good. You're not allowed to read it. You can't read it. Cole.
Rip it apart. I'll
You
rip it.
can't. You didn't rip.
That's how it works.
Exactly. Put my face back up. This is fine. Exactly. Why do you want to see it?
Because it does.
This
is weird. He has a
How?
fortune. He has a fortune from a fortune cookie in his phone.
I left it in there for good luck.
Isn't that embarrassing?
I went through like 50 of them trying to find a good fortune, and he just ruined it.
I didn't even read it.
Dude.
I got M&Ms.
I don't like M&Ms. Brings me
I
down.
want
M&Ms are my favorite candy.
What did you
Joel,
try?
Are they
I
really?
tried
Peanut
to
M&Ms
murder
are my
Sam with a piece of chocolate.
Maybe I'll get some peanut M&Ms tonight.
That was funny.
It's Halloween.
I mean, you could pass for a 4-year-old.
Oh my gosh, these are so nice. I just made my day. I can't eat them now.
I have like a lot of starters.
Right? Right?
You should probably wait just a minute.
Maybe when I'm done with all my
Maybe then.